Hello. This record is about copy process in Inventor. First, talk about mirror copy process and then array copy. Okay, start. Inventor. Well, study on mirror copy process. Open an already created file to save time instead of creating the file from the beginning. Well, yes, I see there is an Inventor file in the memory. Close this drawing file from the previous studying, and then here open an existing file and then say that this one, for instance, it is an Inventor file. Open, and then using this model I'm going to demonstrate the things to do for creating the mirror copy of the existing one. Okay, you know, in 2D AutoCAD, mirror copy process requires mirroring line, but in Inventor 3D environment, mirror copy process requires mirroring plane. The things to do are the same. Not a matter software is AutoCAD or Inventor. Mirror copy. While saying, by the way, mirror copy in AutoCAD environment. Yes, this is the existing solid model in AutoCAD. This is AutoCAD. Okay, and then mirror copy process. I'm going to create the copy of this prism. Okay, using the copy facility of AutoCAD. Okay. Modify panel, mirror copy tool is over there. Start the process and then indicate the object, press enter, and then saying mirroring line. In AutoCAD mirroring line, I'm going to indicate using snap facility, yes, the mirroring line. Here 3D rotate, expand, scale, okay. Well, the mirroring line, try to find a line and indicate. Of course, the line now ready to be indicated in XY plane. Okay, say that this is the first point and this is the other point. Okay, and then shall I erase the source object after creating it as mirror copy? The answer is no. And then you see here I created the mirror copy about that line. Yes. But in Inventor, well, need to show a plane, not a line. Well, if the mirroring plane is the surface of the existing model, then yes, it is quite easy. Click on mirror copy button, start the process. Okay, if you're going to create the mirror copy of the entire of the object, select this option, mirror solid option in the dialog box, and then, well, clicked on mirror plane button and indicate the surface. About this surface, create the copy, indicate with a click, and then say OK. That is the mirror copy. OK. One more time, apply, clicked on this, start the process. Well, not the mirror copy of a feature, but gonna create the mirror copy of the entire of the body. Okay, great. Clicked on this button to say, it is to say the copy of the mirror copy of the entire of the object, and then mirroring plane. Clicked on this and then indicate the mirroring plane. Here, create the copy about, say, with respect to this surface. So on and so forth. Yes, mirror copy. Well, as the mirroring plane in this example, I indicated one of the surfaces of the existing object. Well, here in other demo, well, first save this file saying classwork. About array copy process, I said in AutoCAD the previous classwork. Well, this is another classwork in AutoCAD. I said that 3D model can create the mirror copy of a 3D model. So it is the first exercise in this record. So save it in the memory within this folder. Okay, and for today, classwork number, classwork 1, 2, 3, classwork 3, classwork 4, classwork 7, classwork 8. I think it is in the order for today, classwork 9. Classwork 9. No, well, it has, yeah, yes, classwork 9, April 17. Yes. And this one in Inventor, classwork 10. Classwork 10. Save as. The address. Correct. And then surname, write the file name, ID number, CW10, April 17. And then, another classwork here, say that the mirror copy of the existing one is to be created not about its surface, but about a work plane. Select this option, offset from plane, and then say that indicate this surface as the reference, and then have such a work plane, how many units away, into this box write, say for instance 50 units away. Here is the work plane. It is, although it is simulated as if it were finite, don't forget, whenever you have a work plane using one of these listed ones as the tool, then you see the core region of an infinitely large plane. Okay, I'm going to use this virtual plane, work plane, as the mirroring surface, mirroring plane. Start the mirror copy process, click on this process button, and to say that entire of the object, okay, clicked on this button, okay, and then clicked on mirror plane indication button and indicate this work plane. You see, about the work plane, the copy is ready. And then say OK. Yes. Classwork 11. Save as classwork 11 for today. And then now here to demonstrate that the mirror copy is applicable for creating the mirror copy of a feature. For instance, on this surface, take a sketch, right? New sketch, and then create a circle. Okay, and then project geometry process to locate this circle with respect to this edge. I created it as projection. With respect to that edge, I created it as projection. Yes. And then using this projected lines as reference, anchor this sketch. With respect to here, distance is equal to, say, 10 units. With respect to that edge, the center point is equal to 40 units away. And the size of this circle, in my mind, it corresponds to the base of a cylindrical extension is 12. Finish the sketching stage and then apply extrusion process. Okay, for adding such a cylindrical feature. Okay, say that it is length is 60. Yes. And then we'll say that create the mirror copy of the cylinder. Okay, relative to where? Relative to a certain surface. Okay, here is the plane, mirror copy. Start the process. Now here my purpose is to create the copy of, mirror copy of, not the entire of the object, but this feature only. So select this option, mirror copy of a feature, not the entire of the body. Clicked on this, indicate the feature, and then the rest is the same. Clicked on mirror plane, indication button, and indicate the mirror plane. For instance, this is the mirroring plane. And then say OK. You see, using mirror copy facility, I managed to create the mirror copy of a feature. Yes, that is the tool. In AutoCAD, well, mirror copy process is applicable in 3D environment very similarly. Save this file saying classwork 12. And then yes, in AutoCAD, say in Inventor, sorry, well, I want to talk about array copy process. Okay. For instance, create the array copy of the existing things. Rectangular array. Clicked on this button. Okay. And then feature or the whole body. Whole body. Clicked on this. It is to say that create the array copy of all of the existing model. Okay, in which direction? Clicked on direction indication button and then say that in the direction it is parallel to this edge. I indicated such a boundary. Okay, and then how many copies are needed into this box right in this direction? For instance, 20 copies. And distance between each is equal to 50 or little bit more, say that 80. Yes, and then say OK. You see, in one direction managed to create the identical copies, okay, using this tool. Okay, rectangular pattern, but you see, well, if you say, yeah, hocam, it is not rectangle, but in this direction, you see, there is a row. That might be more rows. Okay, then edit it. Yes, since I created this array in one direction, there is only one column, or say one row. Okay, right click the mouse when the cursor on array icon and then say edit. In the same dialog box, then, well, clicked on the second direction indication tab and then, well, similarly indicate a path. Okay, as the path, well, try to find a straight edge to say that as parallel to that edge. This one, for instance, I indicated this, and then, well, saying that in this direction, create, say that 3 more columns. Okay, and distance between them, say that 500, depending on the case, of course. Here you see 1, 2, 3, 4, 5. Okay, but say 3, 1, 2, 3. Well, I see that distance is to be greater, say that 1000 in this example. You see, and then clicked on OK. Yes. See the appearance. You see, from the same set, well, I have 3 columns. Yes. So in this direction, rectangular, in that direction, 3, 1, 2, 3 columns. 3 rows and lots of columns. Sorry, 3 columns, lots of rows. Okay, 1, 2, 3, and so on. Yes, it is possible. We can create the array copy of a solid model in Inventor. Okay, one more exercise if you want. I may quickly demonstrate. Open this Inventor file. This one. And then create rectangular array. Clicked on this one. And then say that entire of the body. Yes. In which direction? Clicked on this direction button and indicate this edge of the prismatic extension as the say path to create the others, say as parallel to the indicated edge. In which direction? Well, there is a green arrow. It is to say that in this direction. If you need to create the copies not in this direction but in the opposite direction, flip-flop, reverse the direction. I said that in this direction create the copies. How many copies? Say that 20 copies. Distance between each, say that 50. Or here 100. Yes. And in the other direction, clicked on the second direction button, indication button, and then indicate this edge to say that in the direction parallel to this edge, create the other column. Say that 3 columns or 5 columns. Okay. And then distance between the columns, say that 150. And then clicked on OK button. Yes. You see, to its appearance, it is like a rectangle. That's why we say rectangular pattern. You see? I think it is clear. If you're going to create the copy of the entire of the body, to have the group in the appearance of a rectangle, then select this option. In the appearance of a circle, select that option. Okay? Yes. Polar array, rectangular array can be created for having the identical copies of the existing model, entire of the model. Okay, array copy process in the following example, just to demonstrate that is applicable for creating the copies of the feature, not the entire of the body, but the feature. But first I want to save this files, saying classwork 13, save as. It is about rectangular array 13. Okay, and the next one, again rectangular array copy for creating the copy of the entire of the model. Here is the other example. Save it saying classwork 14. Okay. Save as classwork 14. Surname, ID, CW14, April 17. Okay. And then array copy process for creating the copies of features. Close this files, finish studying. Okay, to demonstrate how rectangular array can be created, how polar array can be created, and then finally how path array is created. First I'm going to start from that stage. It is going to be a new file. It's a new file, part file, single part. Select this template option after, of course, selecting the unit system, and then clicked on create button. Okay, modeling starts from sketching stage. Okay, I selected one of the coordinate planes to coincide the sketch plane onto it. This is the first coming sketching stage. Create a rectangle, because in my consideration it is in my plan. The main part of the object is a rectangular prism. Okay, in which size? Dimensional constraint. In this direction 200. Press enter, zoom out if necessary. In the other direction, okay, I don't want to call my memory on the numbers, so let me say that prism is a square prism. In this direction it is also 200. Okay, finish the sketching stage and apply extrusion process. Yes. Thickness of the prism, let's say, is, okay, I don't know, can say that 60. Okay. Finished. Save the file saying classwork 13, 14, 15. Okay. Save as classwork. These are short to their times and their contents. Short classworks and not so difficult to study. You may say that, ya hocam, too much classworks, lots of classwork, but these are, just to record in the memory of my computer that I talk about such things. A very short demo and then save. Lots of files, but say each of them not so time-consuming thing to deal, and also to watch the video record. Okay, surname, ID, and then CW 15, I think. April 17. And then continue. Okay. Now, take a sketch right on the surface of this prism. Why? Because it is my plan. Over the surface there will be a rectangular pattern. Create the first element of the pattern. In this example, the element of the pattern is in cylindrical shape. So in this regard, create a circle in the vicinity of one of the corners arbitrarily, and then, sketch technique is modern method. Apply project geometry process, have the projection of this boundary, have the projection of the other boundary. Why? Because I know the location dimensions for the center of the circle relative to here and there. Dimensional constraint from this projected line to the center in the vertical direction, this direction, distance, let's say, is 10. Okay. In the other direction, yes, relative to here, the center is, since the surface is square, can use the same coordinate, why not, 10 units away. After bringing the center to the correct place, in this example at which it uses 10 and 10 as the coordinates, well, size the circle, say that the diameter of the circle is 12. Okay, finish the sketching stage, and then, well, create the first member of the family. It is a cylindrical extension. This is the dialog box, and then the length of the member, the element, the feature, let's say, is I don't know, 40. And then say OK. Yes, save the file, update it. After creating one of the members of the pattern, yes, for the convenience, create the one it is at the corner of the pattern, then the rest is copy process. Clicked on this button for having an array, rectangular array, rectangular pattern or array. In AutoCAD, well, in the terminology it is written array, but in Inventor, pattern. These are equivalent words. Start the process, and then my purpose here in this example, not to create the copy of entire of the body, otherwise I would click on this, but the copy of this feature. So feature indication button is feature option is correct. This button is the correct option to toggle it on, because it is to say that copy process is to create the copy of a feature, and then indicate the feature, bring the cursor to the vicinity of that feature, and after highlighting, seeing the highlighting, make a click. I said that this. And then in which direction? Clicked on direction indication button and indicate this H. It is to say that create the copies in this direction. If the copying direction, the direction for the copies is wrong, you see the green arrow, it appears after clicking on the direction, after direction button, and then indicating a certain such a reference to say parallel to it, then see such a simulation, a green arrow we have. It indicates the sense for the copies. If it is wrong direction, then flip-flop it. Clicked on this and reverse the direction. Okay. And then into this box, write the number of members in this direction, totally in this direction, or along this row or column, depending on the case, point of view, how many elements you're gonna have. Say that 10. And then the distance between them, write the distance, okay, say that 20. Yes, it is about to be created. If there will be only one row, then click on OK. But if there are some other rows, then click on second direction indication button and indicate one more path to say as parallel to this path need to have the other columns. Well, the green arrow indicating the direction toward the atmosphere, no, it is wrong. Clicked on this flipping button and reverse the direction. Okay, how many columns we need to have in the pattern? Say that 10 columns. Distance between them, say that 20. In this example, it is so. Well, offset distance written into this box, and into that box we write the number of elements, number of columns, here number of rows. Okay, but here you see 10 by 10, 100 is the total number of elements in the pattern. Then the rest obvious, clicked on OK button. Yes, 100 times 100, we have, say, 10 by 10, 10 times 10, we have 100 identical cylindrical extensions. Well, in engineering application, adding such extensions, we can create the surface area, okay, at this side. For instance, if you calculate the area at the opposite side, it is equal to this by that. But here at this side, opposite side, adding these extensions, we managed to increase the surface area. Okay? In heat transfer, to be able to increase the amount of thermal energy to transfer, it is a common technique. Add such extensions over a surface to be able to increase the contact area between the object and its surrounding. It's a common technique. Okay? Yes, assume that it is the case in the example. Say material, it is made of which kind of material? Assign the material, clicked on this button, you know. If you say, hocam, it is very little in size, then clicked on tool step, and then can find the same button in a greater size. Okay, this is the material selection browser. Say that our object is made of aluminum or copper. It's a dark tone, gold, better, very expensive. Say that it is made of aluminum. Right click, assign. Now it is the solid model of the object. Okay. Rectangular pattern is okay, I think. And then how about polar array? In answering this question, well, at this site, I'm going to create a cylindrical extension and then a disk. Take a sketch right on this surface. Okay, and then create a circle. Now, sketch plane is coinciding with the indicated surface of the prism. I'm going to anchor the center of this circle relative to this edge, relative to that edge. So, well, for having the projections of the edges, apply project geometry process, indicate the edges and have their images, and then can snap them. Indicate this boundary as the reference, indicate the circle. This direction, say that the coordinate is 30. Okay, relative to here, the coordinate of the center is 100. Size of this circle, say that is 30. Finish the sketching stage and apply extrusion process. Okay. Yes, since there is only one closed profile, Inventor automatically sensed it and started the simulation. Well, here the length of the cylindrical feature here, let's say, is 100. Then say OK. Yes. There is such a cylindrical extension. And then take a sketch right on the tip of the cylindrical extension, left click and right click new sketch. And well, have the projection of the edge of this surface. Why? To be able to snap the center. Okay, now center point after having the projection can be indicated. Create a circle. Okay, arbitrarily, or if you know that center point is to be coincided with the center of this boundary, then well, start circle creation process and can snap the center of the projection. You know, I created the projection of the boundary of the tip surface, flat surface of the cylinder. So in sketch plane, the center is a characteristic point and it can be indicated. I brought the cursor to the vicinity of that point. You see there is a green ball, means Inventor ready for our indication. I indicated to say that the center point is the same point. Okay, for this circle, its size, let's say, is 100 and maybe what, 160. Okay, and press enter. Finish the sketching stage. You see in the space I have a circle. The area bounded by the circle is the profile. Apply extrusion process. Indicate this profile and that profile, both of them. Thickness of this part, let's say, is 10. And then say OK. You see here I have a disk. Well, if I orient it like this, it looks like billboard. Okay. Now I created this disk as a feature. Why? To be able to demonstrate how a polar array can be created. How this tool is used. Okay. Well, save the file. Classwork 15, I think it is still the same classwork, but here, after having the pattern over the surface of this disk, I'm going to count it as classwork 16. Okay, create the first member of the pattern over this surface to have a pattern, circular pattern. Take a sketch right on the surface. You know how, left click, right click, new sketch. And then create a circle arbitrarily. In my mind, this circle corresponds to the base of the one of the members, the first members of the pattern. Okay, well, if the pattern is about a central point, in practice we use its radial coordinate to locate it. Well, the distance from the center to the center of this surface, say that radial coordinate. To be able to indicate the center of this surface, well, projection process is needed. Project geometry process, apply the projection for having the projection process for having the image of this boundary. After having this green line, it is the projection of the indicated edge. Its center can be snapped. Okay, dimensional constraint. Indicate this projected line as reference. Indicate the circle. Click. And then, you know, in Inventor, if after indicating two entities, these are circles, this means, well, if indicate two circles in sequence, then Inventor will understand that you mean distance between the centers. If you move the cursor too much away, then Inventor conclude that the coordinate distance between them is in the horizontal, or if you move it in that direction too much, saying too much, I mean not few millimeters but more millimeters, then Inventor will conclude that your purpose is to measure the vertical distance. But if your purpose is to measure input radial distance, shortest distance from center to center, you know the trick. Move the cursor few millimeters away from the line it joins the center points. Imagine such a line in your mind, and then click the mouse. It is a trick. Yes, if you move the cursor not more units but few units only, and then click the mouse, then you see Inventor understood that distance to input is the radial distance, the shortest distance. And then after that, make one more click to take a right to input the value. Say that the radial coordinate for the center of this with respect to the common center, it is the center of the surface. Surface is a circular surface, you know. Let's say in this example is 70. Okay, and then after this anchoring stage, well, indicate the circle and say that its diameter is 10. finish the sketching stage, and then the rest, first create the model of the element. In this example, it is again a cylindrical extension. Okay, it's just an example. It might be any other, but say it is the profile, so the corresponding feature is a cylinder. Okay, its length, let's say, is 60, and then say OK. Yes. After creating the model of the first member, for creating the circular pattern, the rest, apply the process, copy process, circular pattern. Clicked on this button, and then my purpose is to create the copy of feature, so this button is correct. Well, feature indication button is on. If not, make a click and toggle it on. How you can understand that the button is on or off? If it is on status, in it is on status, it has been toggled on, either by the software, some cases automatically it is done, or manually by yourself. Then the background color of the button will be blue. If it is gray, then this means it is off. Yes, this is on. This means I can indicate the feature. With a click, indicate this feature. It is to say that copy of this feature. And then axis of rotation, axis of distribution. About which axis gonna create the pattern? That is the question. Well, you know, for cylinders, for conical parts, in general, for revolved features, axis, longitudinal axis is defined. So Inventor knows that under agreement, it is under agreement, the longitudinal axis is defined for a cylinder. You know, this disc is a cylinder. Just to say that the axis of distribution for the pattern is, it is longitudinal axis. Bring the cursor to the edge of that revolved feature, and with a click, indicate. Of course, say I made a mistake. First clicked on axis indication button, and then indicate the edge of the feature. It is a revolved feature, and for which axis is defined. Yes, you see, after indicating the edge of the revolved feature here in my example, this example, it is a disk. Inventor understood that the axis of distribution is, it is longitudinal axis. In the simulation, the simulated long dash, short dash, this line is the longitudinal axis of the disk. Okay, it is not a real line, you know, it is by definition. And Inventor, in its default configuration, ready to create 6 members, totally 6, including the existing one. It is the default value. Say that in our example, not 6, but 18. Distribution angle into this box, right? Full. And then the rest, clicked on OK. That is it. Yes, you see, no difficulty. Since the axis is defined for a revolved feature, to say that about the axis of this disk, just at this stage indicated the edge of the disk, and the rest is achieved by the software. Clear, I think. Okay, save the file, save as classwork 16 for today. Okay, and then, well, relatively more difficult case, say that the polar pattern is required over a surface, yes, but it is the surface of a rectangular prism. You know, for a rectangular prism, longitudinal axis is not defined. So at the axis indication stage, there will be a difficulty. I want to demonstrate how such a difficulty is overcome. Okay, start to this classwork. Well, for creating a pattern, not over such a surface, it is the surface of a revolved feature, and for which the axis is defined, but over that surface. Well, it is the surface of this square prism. For right prisms, rectangular or square prisms, or trapezoidal prisms, symmetry axis is not defined. You know, longitudinal axis is not defined. So since there is no axis definition, then how we can create the copies about a certain axis? That is the question. Reach to that stage and then I'm going to answer. Take a sketch right over this surface, new sketch. Okay, and then, well, create a circle. In this example, again, the members of the family just are cylindrical extensions. So create it as base arbitrarily. And then locate this one, since it is the base of one of the members of the family, and the family is a circular distribution, using the radial coordinate. First mark the point. It is the point to have at the place about that point the circular pattern gonna be created. In this example, well, say that the center of the distribution for the polar array is the centroid of the surface. Okay, I mark the point using point marking facility, and then dimensional constraint. Project geometry with respect to this edge, with respect to that edge. Dimensional constraint, from this projection to the point, distance is equal to 100. You know, surface is a square surface. Its size is 200 by 200. So the coordinate of the center of the surface relative to this edge is 100 in this example. Relative to the other boundary, since it's a square surface, center of the surface is 100 millimeters away. Yes, I located this point. It is the center of the surface, and also it is, in this example, the center for the distribution. Since it is the center of the distribution, for having the base of the member, okay, at the correct place, well, input it is radial coordinate. Dimensional constraint, indicate the circle or it is center, which one you like. Indicate the other point, and then you know the trick. If I move the cursor too much, then program will measure linear distance, not radial distance. But if I move the cursor few millimeters only away from the line, it is to visualize that which joins the points to each other. Outwardly move and click the mouse. Now I achieve to teach to the software that my purpose is to input this shortest distance, not delta x, not delta y. And say that the coordinate is equal to, I don't know, can say that 80 in this example. Okay. Yes, anchoring stage. And then, well, sizing stage for this circle. Say that its diameter is 12. Finish the sketching stage. And then apply the extrusion. Yes, that is the profile. And then the length of the member, let's say, is 80. And then say OK. You know this. If a fresh sketch is indicated and used as a profile, and then in the dialog we say OK, then sketch will disappear from the screen. OK. I need to call the sketch in the sketch because I have the valuable point to the screen, to the environment, because I'm going to use it one more time. Why? Because for a rectangular prism, axis is not defined. To say that about this axis, then there should be an axis, virtual axis. Say actually all the axes are virtual, but here since the axis is not defined for the rectangular prism at this stage, if we indicate the edge of this prism, then, well, the distribution will be created about this line, not about the axis of the prism, because axis is not defined. But if it were a revolved feature like this, then indicating the edge, I would achieve to say that longitudinal axis is the axis of distribution. Such a case, well, need to use this facility, work axis facility. I'm going to select this option, okay, normal to a plane and passing through a point option. Yes, I need to use an axis, okay, it must be perpendicular to this surface and it must pass through a point. Which point? Well, since in this example I said that this distribution is about the center of the surface, okay, well, the axis is to pass through the center. I already marked the center of the surface, so, well, just as the visibility of the sketch. In that sketch, I am sure I already marked that point. Okay, I use it for locating the base of this extension, okay, using the radial coordinate. So I'm sure that point is in the sketch. Well, using which sketch, using that sketch created which feature? This cylindrical feature. So find the icon, it corresponds to that feature, okay, and then to be able to make this sketch, okay, visible again, since in creating this cylindrical extension I use that sketch, and in the sketch I have the necessary point, okay, to use. Well, first clicked on this associated cross, drop this list, and in the list can find the sketch icon. It corresponds not to the sketch, not to the sketch of this, not the sketch of the others, but sketch of that one. And in this sketch I have the necessary point. Right click and then make the sketch visible, selecting visibility option. After making the sketch visible in the screen, then, well, that point you see is visible, so it can be used. Start the work axis creation process, selecting normal to plane through a point option. And after starting the process, indicate the surface to say that axis is perpendicular to this. Indicate the surface with a click. And then system asking, okay, then work axis is to pass through which point? Indicate this point, and that is it. You see the orange colored line in the screen, there is a thin line, please distinguish it, is the work axis. Yes, I think you understood how. And then the rest is quite easy. Now, although the axis is not defined rectangular prism, using this facility, you know, this tool, managed to have an axis. Now, as if axis is defined, can deal with the rest. Clicked on array copy process. My purpose is to create the copy of the feature only, so this button is correct. Indicate feature indication button is on, indicate the feature, and then indicate, clicked on axis indication button, this button don't forget, and indicate the axis. That is it. How many elements do you have in the family? Say that 18 elements. Distribution angle, right the angle into this box, and then say OK. That is it. You see, it is a little bit tricky. Trick is the work axis. You should know that work axis is not, since the axis is not defined for rectangular prism, okay, for creating the polar array, work axis is needed. Okay, then I use the same sketch one more time and finish the studying at this part. So the good practice is that, you know, hide the sketch, bring the cursor to the browser, find the sketch icon. While the cursor is on that sketch icon, right click the mouse and deselect visibility option. Work axis, I use it, but thereafter not necessary, not a good practice to keep that work axis in the screen. Find the work axis icon, right click the mouse and deselect visibility option. This is good. And then save this file saying classwork 1617. Save as classwork 18. Okay. And then finally, talk about pet array. There will be two different pet arrays. Well, one pet array. Take a sketch right over the surface. Okay, and then create a line. Like this. It is gonna be the path. Project geometry process, have the projection of this edge, have the projection of that edge, and dimensional constraints. Relative to this projection, the inclination angle of this line, it is to use a path. Say that is 8 degrees, not 13, made a mistake. Press escape button and double clicked on this constraint. You know, it is the editing technique 8. Okay. And the terminal point of the path, if necessary to specify it, dimensional constraint. From here to this terminal point, distance is equal to, let's say, 15. Okay, from this boundary to the terminal point, distance is equal to, let's say, 6. Okay. Well, I created this line as the pattern, and then, well, create the first element. Well, in this example, the members are rectangular prisms. This is the base of one of them. Dimensional constraint from here to the corner or to this edge, distance is equal to, let's say, 6. Okay, from this edge to the corner, distance is equal to, let's say, I don't know, say 15. Okay, the width of this rectangle is, let's say, dimensional constraint from here to there, distance is equal to 20. Okay, and from here to there, distance, let's say, is equal to 8. Okay, finish the sketching stage and then apply extrusion process. Yes, to be able to create one of the elements, the model of one of the elements, its length is, let's say, 60. And then say OK. Yes, this is the first element of the pattern. It's a path array. Where is the sketch? I need to use the same sketch. This is the icon. Creating that feature, I use the sketch for the first time and it has disappeared. Make it visible. Click on the listing arrow and select sketch icon. Right click and visibility. After making the sketch visible, then I can use it again one more time. Why? In that case, to indicate this line as the path. Well, in AutoCAD, you know, there is a special button in the list, path array. But in Inventor, there is no such an option, but we can use the rectangular pattern creation tool in creating path patterns also, path arrays also. Start the process, clicking on rectangle array creation option. And well, indicate this button is on, indicate this rectangle as the feature. And then clicked on direction button. And as the direction for the copies, indicate this line. It is the path. Okay. And then into this box write how many identical elements you're going to create. Say that 10 identical elements. The distance between them, let's say, is 18, or say that 20, or say that 30. You see, I'm trying to find the number just in this demo because I didn't make any calculation how many over the surface, how many members can be created. So I said 10. But I see that 10 array cannot be created at 30 units away over the surface. I see 3 of them will be in the atmosphere. So say that not 10 but say 5. totally. Or 6, try 6. I think 6 is okay. And then clicked on OK button. Or you may use this tool. Instead of selecting space option here, select curve length option. Okay. Then if you say that select curve length option, then along the curve, considering the length of the curve, then Inventor automatically determines the distance between them. And Inventor, after saying that 6 identical elements, then located them accordingly. But if I say that not 6 but 8, then yes, the distance between them will be shorter. And you see Inventor using the total length of the path, you see specified, determine the distance between them. Okay. Example on path array. It's created the paths, and then the good practice, hide the sketch. Not a good thing to keep this path and the other things in the sketch plane visible in the screen. So hide them. Right click when the cursor on that sketch icon and deselect visibility option. Okay, classwork. 17, I think. Save as. 19, classwork 19. And now, finally, in this video record, I want to talk about, as an example, how an Excel data is imported to Inventor. Actually, this question is not related, directly related with array copy process. But say that there is an Excel data. It corresponds to the coordinates of some points. And those points are needed in Inventor. In this example, to make it reasonable why such a data is needed in Inventor, say that, for instance, for having the necessary path. Well, path is a curved path. Instead of marking the points, well, take a sketch, right, for instance, over the surface, new sketch, and then mark the points one by one. Mark arbitrarily, and then for those points, okay, input xy, 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 xy coordinates. It is possible, okay, and then, well, after marking the points, start line drawing process. What? Select from this list. If you know that the line is fit to the onto the points is a curved line, select spline option and then indicate the points which you already located them one by one. It is possible, but it is too long, of course, if you have Excel data. So undo, and then see. I'm going to use this data. Well, this is 3D, two-dimensional. I'm going to delete these two columns. Just okay. Well, in the memory of my computer, there is one more Excel file. It is in this address. Okay, and where I have two-dimensional set. Yes, since the surface is a two-dimensional surface, and Excel data is also two-dimensional. Well, these are corresponds to x and y values along A column, along B column. For each point, I have coordinate values, and totally 18 points. Well, over the surface, if you attempt to mark the points arbitrarily, and then for each write this coordinate values relative to a common point, it will take lots of minutes. But since it is available in the memory in Excel environment, then just to save time and effort, export it. Or in Inventor can say import it. How? See how. In AutoCAD, I already demonstrated in the previous video record how an Excel data can be transferred. Saying that, remember, in AutoCAD, AutoCAD requires the XY values if it is 3D data, XY and Z values within the same cell along the same column as separated with commas. But in Inventor, there is no such a thing. Inventor directly accepts the coordinates of the points, along different columns. No need to unify them. No need to concatenate them. No need to have the XY values within same cell as separated with a comma. Can be directly imported. See how. I'm going to import the Excel data over the surface. Take a sketch right over the surface. Okay. And then in sketch mode, yes, here is the button to click. Insert not AutoCAD file, not a picture photograph, but insert Excel data. Clicked on this button and then start the process. And then in the dialog box, show the address. Where is the Excel file in which I have XY values of the necessary points? I know it is in this folder, this subfolder, that subfolder, and Excel files folder, and 2D Excel file. Yes, it is the Excel file. And then if you're going to have the points only, okay, just simply clicked on open button. Then the points will be magically marked, okay, transferring the coordinates from this Excel file. But if your purpose is to have not only the points but also the curve, it is to fit onto the points, then well, there is a trick. Clicked on, after indicating the Excel file with a clicked in this list, clicked on Options tab, and then you see default option. After clicking on Options tab, you can see the list of the options. Automatically selected option is to have the points only, because it is written create points. Which points? Just the points correspond to the Excel data. But if your purpose is to create the curve, it is fit onto the points, clicked on create spline button. At this point in Excel environment, okay, using the tool of Excel, insert, okay, select this 2 column and then say that insert a curve. Test it. I see that curve corresponds to those points. It is the curve, it is fit to the points. Onto the points is a curved line. It's a spline. When you created the plot the curve, if you saw that it is a straight line, then at that stage select create line option. But I'm sure it is a curved line, so select create spline option. And then say OK, and then say open. That is it. Here is the curve, you see. The points to their coordinates transferred, and Inventor also created the curve, fitting the curve onto the points. Okay, and then this is the path to have over the surface. Well, sketch plane is coinciding with the surface, but this curve is not over the surface yet, because Excel data, the origin is not at this corner. But in this example, say that it is the terminal point of this curve must be at this corner. Okay, project geometry to be able to snap the terminal point, have the projection of either this edge or that edge, which one you like, and then start the move process. Clicked on this button and indicate the curve in move process. Sorry, selection button is on. Indicate the curve at any point with a click, and then base point. Clicked on base point indication button, indicate this terminal point, and then take the curve and locate it to the corner. No, I'm going to locate it at the midpoint of this boundary, this projection. Where it is? It is over here. And then clicked on done button. Yes, it is the path. And then, in this example, quickly finish the rest. About this point, create a circle. Size it. It is diameter, let's say, is 10. Okay. And then finish the sketching stage. Clicked on finish sketch button. Apply extrusion process first to create the model of the first member. It is over here. Say that it is length is 60. And then say OK. Well, this is the first member. Where is the path? Since I used that sketch for creating this extension, sketch has disappeared. But I know how it is re-invoked. It is invoked. Clicked on this listing arrow, find the same sketch icon. It corresponds to that sketch. Right click the mouse and say visible, visibility. After making it visible, the rest. Path array. Well, in this example, yes, the valuable part this classwork is that how an Excel data is imported to Inventor and how the curve is fit. I think I managed to answer that question. And then, yes, the rest is array copy. In this example, why I asked this, I had this curve just to be able to create the path array. Okay, rectangular pattern, although it is rectangular pattern, well, indicate this feature. Clicked on direction button, indicate this path. Okay, and then along the path, create the copies. Well, say that 6 copies are needed and distance between them in this direction, I know, say that 30, not 30, let me say 20. Okay, 1, 2, 3, 4, 5, 6, or say that 7. I think one more cylinder can be created. And then say OK. Yes. You see, along the path, managed to create the pattern, path array. And then the good practice, hide the sketch. Right click and deselect visibility option. Yes, dear students, I think it's okay. I educated you how an Excel data can be imported to Inventor. And then there is one more time, array copy process, path array. Here path for this array is a straight line, but that one is a spline. And for having the path here, I use the Excel file. Okay. Save this file, saying in other classwork, save as classwork 20. My dear students, now from all the aspects I talked about array copy process in Inventor as well. Stay healthy. Ending this record. Bye bye.